On behalf of COMP90043 Group73, I'd like to welcome you to our presentation about blockchain security and scalability. We will talk about the architecture of blockchain, the technical standard used, and its scalability difficulties and solutions. First, I'm going to talk about the architecture of blockchain from different aspects. What is blockchain? Blockchain is a decentralized, distributed database technology, which stores data in crypto chain blocks on a large computer network. Since the whole data is stored on numerous computers worldwide, it uses distributed nodes consensus algorithm to generate and update data and use cryptography to protect the data when transmission and access to ensure the integrity and security of the data. A key difference between blockchain and the traditional database is that the way the blockchain stores data is to store the data in blocks and then use cryptography to connect the blocks one by one to form a chain. Data or transmission information is packed in blocks. After a block is filled, the block is added to the chain. When these blocks are added to the chain, they will have a timestamp. Each subsequent block will record the hash value of the previous block, so that the content of the current block can be confirmed only by calculating the hash value again. The hash function is a one-way function which calculates y using x, but is extremely hard to find x using y backwards. Any changes to the block's information will result in a change in the hash value. In the blockchain system, each node will keep a copy of the same data. In this way, in the event of data tampering or loss, the problem can be quickly identified. Also, a very important point in blockchain is consensus. Even if someone tampered with the data, it is different from the data of all other nodes in the system, and the tampered data will be discarded. To truly tamper with the data in the blockchain requires that the information of more than 51% of the nodes in the computer network to be tampered with to account for a large proportion of all the numbers, which requires a huge computing power and resources, because they need to generate a huge number of blocks of hashes and timestamps. More on blockchain consensus will be discussed later.
Moreover, I will introduce the technology standards that are used in blockchain. The first one is the hash function. Hash function is one of the most important components in blockchain technology. For many operations, hashing is a method of applying a hash function to data, which is used to calculate the relatively unique output called message digest for the input of any size. It allows the individual to independently take the input data and hash that data and derive the same result to prove that there is no change in the data. Even a slight change to the input will result in completely different output digest. In blockchain technology, the hash algorithm must satisfy with primage resistant and second primage resistant and collision resistant. The SHA-256 algorithm is a hash algorithm that widely used in blockchain technology. The hash function is used in many important tasks like the address generation and the unique ID generation. And as mentioned before, the block header will contain the digest for the block data to scale the data not being changed. Besides, the asymmetric key cryptography is important in blockchain. User can use the public key to encrypt the message, and only the user who owns the private key can decrypt it. And the user can use the private key to encrypt the message, and others can use the signer's public key to decrypt and verify the signature. Asymmetric key cryptography provides a mechanism verify the integrity and authenticity of the message while allowing the message to remain public at the same time. Asymmetric key cryptography is used in blockchain to sign the transaction digitally. User can sign the transaction by the private key, and other user can verify the signature by using signer's public key. And also, as mentioned before, the user can use the hash function with the public key to generate the address which is used for transfer. As the blockchain technology is based on the distributed system, blockchain need to ensure every node should have the same state and keep constant, but every node is untrusted between each other and the communication between nodes is not stable. The consensus model is used to solve this problem. The famous The famous consensus model called proof of work is one of the famous consensus model in blockchain. The node will calculate the nonce, which is a random number when the new transaction happen. And the first node which calculate the nonce successfully will add this block to the chain and send it to other node. Other node will verify this easily and propagate this block and start to calculate another new block. But it is waste a lot of resource.
In the third part, we will talk about scalability in blockchain. The scalability in blockchain means the number of computations processed by blockchain network per second. The higher scalability, the less time the blockchain will spend on one transaction on average, which means the blockchain can serve more people. The scalability depends on two main factors, the size of block and block generation rate, which measures blockchain throughput. Abbreviated as TPS, the number of transactions that a blockchain can confirm per second. Well, we can't simply increase scalability. For example, if we increase the size of block to increase scalability, which will make the problem that it will take more time to send one block from one node to another one. And the confirm time in blockchain will be exponential growth for the reason that the block must be broadcasted to the whole nodes in blockchain. Unless we use less nodes or other cryptography method to confirm transaction, the time cost is unacceptable, which means the decentralization and the security will be affected. This is also known as the blockchain scalability trilemma. The blockchain scalability trilemma is one of the greatest handles for cryptocurrencies. It states that you can only achieve two out of either decentralization, scalability, or security simultaneously, but never all three. Therefore, trade-offs are inevitable. The trilemma was originally coined by Vitalik Buterin, the founder of Ethereum, who invented the name regarding the scalability of blockchain technology. There are three main kinds of solutions for scalability based on different layers where the method perform. In layer of 0, which is known as the data transformation layer, blockchain can use different data transfer protocols to increase scalability. In the first layer, which is known as on-chain layer, blockchain can change the protocols of public blockchain to increase scalability, such as segregated witness, directed acyclic graph, sharding, new consensus protocols, and so on. In the second layer, which is known as off-chain layer, blockchain modify application layer inside of basic protocols, such as using state channels, sidechain, cross-chain, off-chain computation, and so on. That's all. Thank you for listening.